I'm just going to start with this guy. His name is Neuroskeptic. I don't know if you've ever seen this before, but this is an academic article. Have you ever seen a pseudonym on an academic article? He took Dante's Inferno and talked about, the scientific nine circles of scientific hell. He made all sorts of different practices that seem to be very prevalent in 2012. So there is the overselling, there is post hoc storytelling, partial publication of data so you don't share everything, p-hacking, questionable research practices, creative use of art. So now we call this a lot of, but it does have plagiarism there. And there's the ninth circle of hell, which is inventing data or fabricating data. Sometimes, and I think we do this to some extent, especially with questionable research practices. Have you heard of Diederik Stapel? How many of you have heard of this guy? Some of you have, many of you have not. The dean of psychology, the dean of social sciences in Tilburg University in the Netherlands. So I told you about the beginning of the replication crisis in 2011, and I told you that everything started with BEM feeling the future as if this was the only thing that happened in 2011. But maybe even bigger than this was Diederik Stapel. Diederik Stapel was considered to be a genius in the field of social psychology, has published papers in Science and many of the top journals. Really very, very well known, has charisma, changed a lot of things in Tilburg, has a lot of papers, very prolific, 137 published papers. 2011, something happened. I'm going to play for you one of the people that found out about this fraud case. How did they find out about this and what did they do in order to make sure that this is real? I think what's very different about this case study compared to other case studies, so with Francesca Gino, for example, we'll get to her, she declines everything. Diederik Stapel did not last very long. So at some point, very fast, within I think the second meeting, he just admitted to fabricating everything dating back to his PhD. So from his PhD level to becoming a dean of psychology, 137 published papers. He did not write those alone. He wrote this with a lot of PhD students, with a lot of collaborators, a lot of postdocs. A lot of people have published and got jobs based on things that they did with him. So when a dean of psychology that has published 137 papers admits fraud, it means that everybody that has ever collaborated with him is now under suspicion. And as they started looking at all these papers, this slide I think is from 4 or 5 years ago, so 54 retracted to date. Probably every paper that he has ever touched or contributed data to has fabrication. Now you can try and think what goes on through a person's mind, not when he's feeling under pressure to play with a bunch of numbers, but for decades to just invent numbers again and again and again and again for 137 papers over his entire career for such a long time. What kind of mindset do you need to have? The amazing thing is that this guy wrote a book and he even gave a TED talk about why he did fraud. And I'm going to play some of that for you. And I want you to tell me what you think about this. Because he seems like a very good, innocent guy. But the impact of what he has done is absolutely devastating. There is no way to even start and quantify the millions of dollars and the number of careers that this has affected. He wrote this in Dutch. However, Nick Brown, who was a PhD student at the time, also considered to be a data thug. We're going to talk about him because he provided a lot of tools for you to be able to detect fraud. Decided that this book was important enough to translate the whole thing to English. He is not a translator. He's a PhD student. He decided that it's worthwhile doing this. I urge you to go and read this thing. It's fascinating. And also, Diederik Stapel, unfortunately, is a gifted writer. So it's also a very entertaining kind of read. So on one side, you laugh. On the other side, you cry, because this is on all of us. How could a person like that go around and collaborate with all sorts of people from all over the world for so long, and nobody has ever noticed this? So I really recommend that you go and you read this. Yoel Inbar, he is now at the University of Toronto. He recently, was a lot of Twitter involvement about a certain thing that he was trying to do, not related to fraud, but he has this wonderful blog that he started with Michael Inslet. And these two folks are both of them are very interesting. So one of the PhD students at HKU, Katie, is now working with Michael Inslet at University of Toronto. You're welcome to reach out to her and talk to her. So both of them started this because of all the stuff that's happening in the replication crisis. Michael Inslet, the reason why he wanted to start this podcast is because he was an ego depletion guy. We talked about ego depletion and the problems with ego depletion. He has spent over a decade on this thing, and he was absolutely devastated by not discovering, that what he has worked on for over a decade just doesn't have anything. Yoel Inbar was a fresh assistant professor at Tilburg University under Diederik Stapel. So I'm going to play to you what he explains to Michael Inslet. So Michael Inslet is asking him questions, interviewing him about this. I do have to warn you, both of them are very colorful people, and when they get together, they drink beers. So it's called Two Psychologists, Four Beers. So it starts with them introducing the beers that they're drinking, and I think after a few sips, you can see they let themselves go. So there is profanity. So I apologize in advance for the profanity, but I think it's understandable in the context of fraud. So there's no text, so you'll have to listen very, very carefully. I hope you'll be able to understand their accents and everything fluently.
So what happened? What made you think this way? How did you get to where you are now?
Yeah, well, I was involved in the Stapel thing was the main thing, and this is funny because it's fraud, right? Which is not p hacking. But I was at Tilburg, when Diederik was there, and I haven't talked about this publicly, but it's not a secret. I was one of the people who reported his possibly fraudulent data to the university authorities. So when I got there, I was a new assistant professor. It was my first tenure track job. I started going to his lab meetings. He was at that time the dean of the School of Behavioral Sciences, so pretty high up, but he was still very research active. And it was just these results were just amazing. Every time, every prediction was confirmed and beautifully.
Wait, hold on.
Sorry.
I want to probe this a little bit. So you're an assistant professor, brand new,
right.
And was he instrumental in hiring you at all, or no, that was unrelated?
Well, he generally was pushing for more international faculty. So this Tilburg is a school in the Netherlands. They had historically mostly hired Dutch people, and he was really visionary in saying, we need to have an international presence and we need to hire people from abroad.
Okay, so it maybe if not directly, indirectly responsible for you showing up.
That's right.
And then within the first semester, you attended his lab meetings, and this is 2010 or?
Yeah, this was 2010.
Okay.
Yeah.
And so even then, this is pre-false positive psychology paper. This is pre-P curve, obviously pre-Stapel.
Obviously.
So what was it? What made you think that what he was producing was too good to be true?
Well, it looked too good to be true. It was the perfectly as predicted means for every study, right? And not just like it mostly worked, it was exactly as predicted every time. And then it turned out that the data were never collected at the university. So he had a hookup with some secondary schools, like equivalent to high schools in the US, where he claimed that the data was being collected, and like graduate students would give him the materials, and then his quote unquote assistants at those schools would collect the data, and you would get an SPSS file back to analyze. And like every time in that lab meeting, it was like, we predicted this, and look how exactly it turned out the way we predicted.
I must admit, maybe I'm just too gullible, but I'm not sure my like spidey sense would have been tingling about that. I mean, I would have been probably just jealous. I would have just been like, God damn it, that Stapel, he just got good ideas.
Yeah.
And I remember, so I had I was friends, I mean, I still am friends with one of his postdocs at the time. And I remember him commenting to me, it's like, yeah, all our studies work. It's amazing. Every time they always work. And I'm like, fuck, man, like, what the fuck am I doing wrong?
Yeah.
But anyway, but you had the good sense even back then.
Well, I've wondered about what that says about me as a person. I was the person who was like, this can't be fucking right. This guy is trying to get away with some shit, So
you were skeptical.
Yeah. I mean, the combination of it always works out as predicted and nobody sees the data collection. I mean, those two things were like, whoa.
Yeah, okay. So the latter thing, that second thing is like, why are you going to a high school? I mean, that's just weird.
Also, I feel like I came from, the Tom Gilovich lab, like, Tom is great. He has amazing intuitions. Like, and there, more than half of the studies didn't work, right? So I feel like that's the best case scenario. Anyway, yeah, so I was suspicious. I talked to a couple grad students that I trusted about my suspicions, and they, in turn, talked to other graduate students in the program. And many of those people had worked with Diederik, and it turns out had somewhat odd interactions. So those students then tried to gather as much kind of evidence as possible. And I proposed to Diederik a collaboration so that I could take a look at some of these data. So I had an idea that I thought might actually work.
But hold on. So this is a legitimate idea, or is it a sting operation?
No, well, I don't know, a little of both, I guess. I mean, I believed in the idea.
This goes on. I recommend that you listen to this. I've listened to this many, many times, and every time I'm just blown away by the courage of doing this. Just think about the sting operation of going to your dean and offering to do a collaboration in order to suggest something, and then see just these amazing, perfect results come back. Any thoughts as you listen to this? What comes to mind when you listen, when you hear them discussing this?
How can no one at the personal level ever be involved with the
Absolutely. Why did it take Yoel Inbar to do this? Everybody sat in all these lab meetings. What kind of science are we in where somebody can always have amazing, beautiful predictions and data? Very good question to ask. What is it in the social norm beyond Diederik Stapel? What is it in the social norms that allowed all of us to partake in a situation that would allow a fraudster to go for decades undetected doing this kind of stuff? Very good question. Any other questions that you have? What other things can we ask?
Sort of this perfect alignment between predictions and results every single time. Surely, as the host has mentioned, even in that top lab that he was in, he only saw 50% match between
Gilovich lab.
Yeah, exactly. And he found that person to be a very I guess accomplished academic in their own right. So I found it interesting that there was no fabrication of that fabrication, in the sense that surely you would be motivated to camouflage some of that.
Just so I understand, when you say camouflage some of that, what do you mean by that?
So essentially, if you were going into data fabrication with the intention of this is going to get me notoriety in both a good sense and a bad sense, then surely you wouldn't want to make it like too obvious. Because I'm actually not that surprised with the data collection taking place elsewhere.
Mm-hmm.
I know of a lot of like clinical folks in the US who use like modeling and other kinds of data sets.
Mm-hmm.
But those are retroactive, right? They take data that's collected perhaps in like hospital visits, like
mm-hmm.
maybe in the late 90s, and then they analyze and build models based on that. So I'm not too surprised about the data collection not being happening like in-house,
mm-hmm.
but I am a little bit surprised at how there was no like camouflaging taking place, because it doesn't look very realistic. I think it's
So I think two very good points that you raise. First of all, this is stupid fraud. Seriously. A guy that always produces amazing findings. And if you read his book, how did he manipulate the data? I know that today it's a lot more common, but even back then, there was data simulation. You can simulate, you can run R code, or you can do all sorts of things in order to produce data that seems a little bit like it look. The guy just sat there for nights on changing things in the raw data, changing one value and then looking at, okay, is it working now or still not working? I'm going to change one more. This is the most stupid way of doing fraud possible. There must be other people who camouflage their fraud a lot smarter than that, right? So we were able to do this. So his spidey sense, his ability to detect that something is off, was because it was too perfect, right? But if somebody would just, do like a 50%, sometimes works, sometimes not, just to create a little bit of noise, if you're really a good psychologist and you know how people behave, then at the very least try to behave like a person would behave, or results that would seem like they're true. But if you do like 100%, it's almost as if it's just a matter of time, maybe 2 decades, but just a matter of time till something gets caught. I think the second thing is about what is our obligation when we hear where data comes from? I think the point about in-house and outside is that in-house, if you have participants coming in, there's a lab, people coming in, people are going out. There is somebody that is involved in this. If everybody comes from the outside, you would have some other guarantees that data collection did take place. So I'm going to talk about the Dan Ariely case, where 15 years later, once contacted the person who allegedly conducted the data collection, asking her, did you do the data collection? She says, I have no idea what he's talking about. So when everything comes from the outside and there's no indication of anything from the inside, at the very least you want to ask, wait, who ran the data collection? In what school? Can I talk to this person? Why does everything need to be channeled through this one person, right? So he's in absolute control. Nobody talks to the people where the data is from, only through me. That gets a little bit suspicious. So on one side, absolutely dumb. The reason for us finding this is because this was dumb. On the other side, it's like, it took such a long time for us to find the dumb case. Can you just imagine what would happen if he would be a little bit more clever? Before we go on a break, I do want you to hear this from him. The citation rate is declining. However, the guy still gets hundreds of citations every year, and not for saying that he is a fraud, but for people who just don't look at whether this involves Diederik Stapel or not. I've seen his work included in meta-analyses. I've seen all sorts of follow-ups to this. People just don't realize that papers have been retracted, because in some of the journals, the retraction is in a very small font in somewhere that you can't even see. Now, there's a long video. I recommend that you watch this because it's absolutely mind-blowing, but there's also a short version just to explain this. And the way that they would do the TEDx is that they would do this on the train. Don't ask me why, but they would go from Maastricht to, I don't know, Amsterdam or somewhere. And on the train, they would listen to a TED Talk. So it looks a little bit strange. He's standing in the middle of the train, but you'll get to hear from him. He's been silent. So aside from the book that just came out and just outstanding in its blatant disregard for anything that he did. Now he's trying to come back saying, actually, I have a psychological explanation for everything that I did, and I have forgiven myself, and I need a job or stuff like that. So I'll let you listen to some of this.
There are many reasons why I did what I did, why I blew up my career and why I invented research data. But I think one of the more important reasons is that I became detached from myself. I lost my own interest, my inner self. I lost my dreams, my power, my passion, my desires. And in doing that, I also lost the connection with other people. I became a sleepwalker. I became indifferent. I was a sleepwalker. I didn't care. I was having fun, I was teaching, I was writing, I was thinking, I had wonderful colleagues, but myself, my true self, wasn't really there. I lost myself. Friends and family gave me that, showed me that, compassion and kindness, and that enabled me, and they forgave me. Many of the people I collaborated with forgave me explicitly. We talked about what happened, and that allowed me, and I think that's perhaps the most important lesson, to be kind and forgiving to myself, because I'm the person who can only forgive myself. There are no other people who can forgive me. Yes, the people are close to me, but not people I don't know and who write about me.
Yourself in the first place?
I find this a cold and unstructured and chaotic world, and I wanted to make it whole and beautiful, and I didn't succeed. And in that, I don't think maybe I pretended I love myself, but I don't think I love myself. I do love myself now more than 3 years ago.
Thank you.
So I'm trying to find work everywhere for 2 years. I was not successful. It's very hard to live with a reputation like mine. I decided now to stand up and not bend over anymore. I have no idea.
Yeah, so he's standing up and not bending over. Any impressions from this very short part of the video? What did you see? What questions do you have? There is an inherent contradiction, almost like a paradox in what he's saying. On the one side, he's very successful, surrounded, publishing a lot of stuff. On the other side, he feels empty and detached, right? Yeah. If he feels that the pinnacle, the highly successful, then that gives justification for everybody who feels anything less than that, right? To behave in the same way. In his mind, both in the book and in this very fascinating talk, to him this seems like a justification, like an explanation of explaining everything that he has done. So yeah, I agree with you. There's something
like very subtle kind of self-harm or self-destruction.
Mm-hmm.
And there's something to call it.
Right.
Like an
yeah. It sounded to me for a second that you're saying something, you're generalizing for what he's saying to our everybody's lives. What?
It's very unhappy.
Mm-hmm.
Yes, because the whole field is built on, I don't know, laborious research PhDs waiting for the people upstairs.
Yeah.
And because you just want maybe a more comfortable life, you start with northern and get rid of the place you just want the result to be better because it makes your life better.
Right.
I think
he talks about this many times. He wants order and beauty in a messy world.
And it's tragic.
It's tragic. Yeah, I agree with you. Yeah. Anything else you noticed? Thanks for that. Anything else you want to say about Diederik Stapel? Yeah, I find it fascinating. He's not the only person who has, been found to be fraudulent, but he's the only one who has tried to make a comeback and did both a book and a TEDx, and not bending over anymore. A bunch of people. We're going to talk about some of the other ones. So Brian Wansink, I don't know if you've heard about this guy, very famous food nutrition scholar that did a bunch of nudging. So over the years, we've got people from everywhere, not just like psychology, but it seems like at least two of them are social psychology, also in the Netherlands. So they've suffered two very big fraud cases coming out of this. But there's like a bunch of other things that are coming out, not as big as Diederik Stapel, but being found by data scientists like Uri Simonsson here, who is part of the Data Colada team that has, if we're talking about like the Francesca Gino, Dan Ariely was also involved. So since 2012 or so, people like Uri Simonsson, the guy here, have decided to put aside almost everything that they're doing and dedicate their lives to the very ungrateful task of trying to find fraud. Yeah, so before we go on, I think we'll take a little bit of a break. Let's do like 10 minutes and come back. So we're talking about this very famous case study. I think some of you already know it. It's funny just how many people saw this figure without realizing what is wrong with it. Why would this go unnoticed? First of all, what is the issue? Let's just all say this together. What is the issue? The error bars. What is the issue with the error bars?
It's a T.
It's a T. It's just a T. Somebody just put a T. So people thought this is a joke. It's not a joke. You can go here. This has a DOI. You can see the paper. And once people started to look at the error bars and see that this is not a thing, they started looking at other stuff as well. So actually the retraction is quite long. I'll just open it for a second. You'll see that it has like a bunch of things that were raised here. Reader concerns a bunch of rotations in the used equations. It's like once somebody does this kind of stuff, it seems like they also do other stuff. But just like with Diederik Stapel, what's amusing about this is just how stupid this is, right? So the clever fraudsters, the clever people don't do this kind of thing. They really know how to do stuff. They do simulations. They know how to press the right buttons on Excel. They know how to create figures that would seem less fraudulent. So I'll just go back to give you an example of how Simonson started with this. Actually, Simonson does a lot of really good work. I don't know if you've ever used him in some of your citations, but he and Data Colada were the first in 2011 to do the false positive psychology, showing how people do p-hacking. So basically, they've shown that if you listen to a certain song, then you get older. Like really, like your age gets older just by listening to a song. So obviously this is impossible. This cannot happen, but they've shown how with very simple steps you can guarantee this kind of result. Then Diederik Stapel, then Simonson said, okay, need to stop with this. We need to start realigning. So I like this case study because it really shows that to be a good data detective, you need to be a good psychologist. You need to understand people and how people go about doing fraud. So sometimes being a good fraudster, being too good of a fraudster, but not understanding human psychology can also backfire. So this is one of the methods that Simonson found out. So it seems like people have, we're going to talk about this maybe in a session or two, next week or the other, about how people interpret statistics and likelihood of all sorts of things happening. I'm just going to show you. Yeah. So for example, with this question, typically at least 50% of sample asks for their willingness to pay for things, generate numbers that are multiples of 5. So if you ask people, how much are you willing to pay? People don't say 3.89. They say 5. And they say 5 a lot more common than they would say 1 or 2. They just like multiples and they like round numbers. It's just something that they do more, and they usually don't use the decimal unless they feel like they really need to. But generally people go for like 5, 10, 15, that kind of thing. So when you have a data set that is completely normally distributed and doesn't have the multiples of 5, then you're like, it's not likely that people created that, especially if it has decimals. But even if it has too many of like 2s and 4s and not as much as, or just as likely as 5. So he was just showing, so what is the likelihood of people answering, for example, Yeah, so it has all sorts of different, I can't remember exactly what it is, but the way that he found this fraudster, where is he? Yeah, one of these two. Yeah, is by showing that the distribution of people using a multiples of 5 is much lower than expected. So for all of these, you can see it goes somewhere between 50% to almost 100% of the sample using a multiple of 5. But for this fraudster, he just randomized everything. So the prevalence of that was about 20%, which is what you would expect from 1, 2, 3, 4, 5. So 20% is like 1 out of 5. So it was just assuming that people would answer 2 as likely as 5. But if you look at real data, you see that this is not the case. So sometimes it helps, like Simonson, to be just a good psychologist and see whether something is likely or not. He starts talking about a lot of these methods and the way that he detects fraud in 2013 with this paper called Just Post It. So he argues, and this is definitely true, that if everybody would be made to post their data, we would find it a lot easier to detect fraud. I'll move to we talked about biochemistry and image duplication. Elizabeth is a hero in many people's eyes. I still pay her salary on Patreon. So when she did not get a tenure track position, she left academia because of a paper that she wrote, and I'll show you these papers. People did not like data thugs or data detectives, did not like her work and did not promote her. So she left academia. And the question is, can she sustain and keep doing her job? So she set up a Patreon and asked people, would you be willing to like buy me coffee every month? $1 here, $1 there. But I'll show you, maybe I have this here somewhere. Yeah, here. So if you want to support her like I do, you can buy her a coffee every month or whatever is suitable for you. And you'll see that right now there's 376 of us that are buying her coffee every month. So she's able, so 329 are fully paid members. And now she has a salary of $2,200 to just like be a data detective and look at image manipulation. So I support people like Elisabeth Bik and some artists that do, I don't know if you're familiar with Melody Sheep, but he does a bunch of really interesting science videos. So it's just a good way for me I can't buy them coffee because they're not here in Hong Kong. So I just want to support their work. So if you like her work, do that. She's now a lot more famous, but like 6 years ago, she was in real trouble. So we weren't sure that she'll be able to keep doing what it is that she's doing. So if you want to listen to her talks, these are from the last year or two. I recommend those. Good stuff in there. This is the first paper that she published that really got her into some trouble. So she, at some point, discovered that somebody used a passage from her paper. How did she do this? She was looking for, she didn't remember, I think, which paper that was. So she just took like what she remembered from that paper and she put it on Google Scholar. And to her amazement, she did not only find her own paper, but she found like a bunch of other papers that also have the same like paragraph. So she just looked at those papers and she realized it's not only the text that they're duplicating, but also she noticed images. So she decided, as part of her academic training, to go through the entire literature and to try to spot with her eyes. So we're talking about 20,000. If you think your thesis is boring, just imagine like 40 journals, 14 publishers, 20,000 papers from the year 1995 to 2014 in biomedicine. And to see how many of them include data duplications. She thought if people are duplicating paragraphs in her papers, perhaps people are also duplicating images. It's a lot harder to find duplication in images, because to find a duplication in a paragraph, you just put things into Google Scholar or Publish or Perish or one of these tools, and you'll find it. Like we talked about at the beginning of the class, to find an image duplication is not easy. However, that said, you can train this. at the beginning, it was difficult for her, but at some point she realized some systematic problems. And with time, she became very good at just detecting these things. And she trains other people. If you want to be trained as a data detective, follow her on Twitter. She posts challenges, asking people, giving them challenges, I know what the answer is, but find the duplication in this image. And she gives like easy, intermediate, and advanced. And she invites people, and then she gives them badges and awards and all kinds of stuff. So now she has a whole following of people who compete. First, they send her a lot of stuff, but they also compete on who gets the badge first, who gets the most badges, and all of that. I recommend this for a lot of reasons. It has allowed me, just by watching other people do this, has allowed me to see all kinds of funky things with figures in, let's say, manuscripts that I go over also as an examiner, where I'm like, what is going on here? This just seems like a Photoshop, like copy paste from a different figure that I've seen. So this is the first thing that brought this whole thing up. So you would ask, okay, so she found that about 4% of all articles have image duplication that she can find with her own eyes. 800 papers. This is not like a small number, especially in something like biology and medicine, biomedical. What then? Thing is, this is 2016, she alerted the journals about this, and she wanted to see how fast they would retract this. What do you think would happen with the journals if you notify a journal about a problem with data duplication, image duplication? How fast do they respond? Years, if they respond at all. Some of them really don't care, and we're talking even about the big impact factor journals like PNAS and all of that. So we have some data. I wish I kind of included the figures in there, but you can see that 10% of the papers with inappropriate image duplications were retracted, which leaves 90% that were not retracted. So she contacted the journals. She keeps asking, did you retract? Did you retract? Did you? They just seem to not care about this. Academic journals that have image duplication, even if this is like a mistake, you would have to ask, like, why are they keeping this? Why is there no investigation looking into this? And she has come to train her staff to be able to look at one publication in an average of 30 minutes staff time. So seems like a small price to pay for the journals to just go over these things when papers are submitted. She gives these three categories about types of duplications. So simple duplication is just, okay, it's the same image appears here and here, not a problem. Duplication with repositioning, you can see that it has different sections of the same photo, a little bit harder to detect. But the thing that is really problematic and not easy to detect is duplication with alteration. So if you can see anything here, maybe I'll just like zoom into it. You can see that somebody copied these trees. They're exactly the same trees, but unless you're a very good data detective, you will not be able to see this duplication. So how does this look in academic articles? These are many examples that she had. It starts from things like figures. So these figures look exactly the same. It almost seems like stupid. It also, she seems like people, this is exactly the same image, but somebody like copy pasted this and blew this up a little bit. So these two green ones are the same thing. And then here in the blue one, somebody just created this in order to force an effect. So she's able to look at this thing and immediately notice that something looks exactly the same. And I have to say that whenever she gives those challenges, and I look at these challenges, I'm just like, what? I don't get it. Like, what is happening? Especially when it's the advanced stuff, but even some of the easy stuff, I'm just like baffled by this thing. But I notice that people who are following her, it becomes easier and easier for them to notice this. So you have like category 2 and you've got category 3. Category 3 is like the most difficult one when you can see like the different duplications. And journals, even after 6 years, you can see things like PNAS no action for over 50% of things. Science doesn't seem to be responding. Springer, Elsevier, it's just unbelievable that we call ourselves science and we don't care about an image duplication, even stuff like error bars, that anybody can see. They don't do anything about this even six years later. So if you want to support her, I can give you her and other people's Patreons looking for this. So I thought maybe we'll do a little bit of an exercise just to wake you up a little bit and give you an opportunity to play a game. So we're going to do different teams. So you're going to work as a team. We all have the same Google Doc, but I trust you to only look at your part. And if we'll open this, this is what it looks like. These are the solutions. I'll just go to this one. So we've got team purple, brown, gray, and so forth. You've got 8 images. And I'm asking you to try and detect the duplications in various images. Okay? Just to make this a little bit interesting, I don't have badges to give you, but I do have sweets. So I brought you some sweets. Yeah, so we've got Snickers, Toblerone, and I don't know what this is. Party burger. So for I would like to give away all of this. So for every correct answer, you will get 2 of these that you can select. And yeah, we'll have 20 minutes for this, but I'm hoping it will not take you that long. You can decide to, whatever way you want to collaborate, how to do this the fastest, how to do this the best quality. I don't know. Decide with your team how you want to do this. But once we start, which is immediately, just go ahead. Does this work or not? Does it open up? Did you crash my website?
I think so.
Okay, just maybe wait for a second and then it will come up again. But yeah, we have all of these. Find your team. And I want you to write. It doesn't work?
No, it works.
Okay, great. So start working on this. We have 20 minutes for this task. Yeah, I'll put this here. It's these types. So if you can also tell me what type of image duplication this is. Is it just a simple duplication? Is it a duplication with repositioning, or is it a very elaborate duplication with alteration? And many of those have more than one.
Is that
Sorry? Yeah, and typically more than one. Yeah. Okay, 20 minutes. Let's see how well you can do with this exercise. Okay, time's up. Let's stop for a second. I know it's a very entertaining kind of exercise. I enjoy doing this. It's a bit like Where's Waldo? Before we check ourselves, I'm curious to hear, what did you feel like doing this? Why is this exercise important? Why are we doing this? What can we learn from this?
I think at one point I thought it was quite obvious. For example, if you're looking at something like that, it's very, very obvious. But then if you're looking at, for example, image 4, it's actually quite difficult to discern.
Yeah, let's see image 4. You're gray, right? Image 4. Oh, this one. Yeah. Who was able to do figure 4, image 4? You were able to find some. Which team are you?
Orange.
Orange. Okay, let's see 4. They found these 2. Maybe I should have done this differently. Maybe I should do it this way. Okay, yeah, this is better.
It's the orange.
So you found 2. You found these 2? Yeah. Yeah, those 2, all right, and these 2. So these 2 are not, so do you see the red one? How did you find the red one? They're not exactly the same, are they?
That's split it off.
Right. Yeah, so not very obvious, right? Some of them are flipped, but if you look at their direction, they're kind of like facing one another, right? Yeah. And here, what's this one here? Just a little bit like a different crop of the same image, maybe. Yeah. Rescaled, yeah. Yeah, good. So not obvious. Some of them are a little bit more sophisticated. Good. That's one takeaway. Anything else? What else comes to mind when you deal with these things?
I think it takes seconds to fabricate these images for hours.
You take what? Sorry?
It takes a few seconds to
A few seconds.
fabricate the things.
Right. If we ever find this out, right? The simple stuff, the obvious stuff, maybe, the stupid stuff, we can find out relatively, with some skill in time, but it's enough for things to be rotated a little bit or flipped or a little bit scaled for us to really get lost with this, right? It's becoming very, very difficult. Good. So very easy to commit the fraud, very difficult to find that. It's not like text. Image duplication and image alteration is very different. Good. 2 insights. Any other insights from this? Why should we do this? We're in psychology. Do we care about this? First of all, some of us are in neuroscience, things are firing up.
Find out where it was like manipulated, and I kind of started to think about what's the purpose of the manipulation. So like, for example, the image. But I can see that for a lot of cases, it seems that they got like good results for one of the two, but then the other one wasn't so good. So they just kind of copied this good one to maybe the one that's not good. And then they just, So it's always like quite systematic copying. So these two are copied to these two.
Right. So I think it's really interesting to try and think about the motivations behind this and why people are doing this. And what is the pattern that keeps coming up in why people fabricate this? And what are the kinds of incentives in our very messed up system that gets people to do this? Like, why would even people have to do this in order to get published? Why would people go and mess around with this kind of stuff? So I spend a lot of time thinking about these things, trying to understand the motivations, and of course, doing whatever I can in order to change the system so that it would not rely on having good duplications or good results, that whatever the results are going to be, they're going to be valuable and interesting, null or found something. It also, you can see the prevalence. It's like some of them fall out. It's like when you see this, it's like, oh my God, what did they do? It's like everywhere. In some of those, it's just something very, very small, which really makes you think, it's like, why manipulate this very small thing? Baffled by fraudsters, especially with this kind of thing. You want to see all the raw data. You want to have access to all the code. You want to run this by yourself. But I can tell you, the more senior you will become, the less and less time you will have for this. I've worked in labs where the PIs have not touched code or data in 20 years. That's a lot of trust, right? Let's say that you get to the point where you just give up on, I don't know how the student did this, or I don't know how the collaborator did this kind of analysis. We're talking about something like network analysis. Let's say I don't know how to run a network analysis. I have an expert. They know how to run a network analysis. I'm just going to trust them. At the very least, maybe I can have some skills in order to see when they run a network analysis and they have a figure. Does it have T as error bars? Does it have some duplications between two different conditions, right? Can I see the reproducible code that exports something that makes it seem real? Okay, so thanks for taking part in this. This was interesting to see. Okay, are you ready to see the outcome? So I'm going to ask you to count your own successes. If you have something that you found that I don't have in my solutions, please let me know. You will get an award, not just from me, but also from Elisabeth Bik. Okay? All right, so we have the solutions here. We'll start with this one. Wait, why can't I? Zoom 200. Okay, so this was a pretty straightforward one. It's like Alzheimer's disease. Like, why would somebody play around with something like, you really don't understand this kind of thing. So here it's just like a very simple one. I hope it works here because, so if you want to kind of like open this in your laptop, you're welcome to. This is the link. It's up on the top of the Google Doc. Yeah, all right. So this is the first one. Did all of you get this? Yeah, that was pretty straightforward, right? All right. Second one. I saw many of you get these two, and many of you get these two. Did you also get the third one? Did any team get the whole thing? Yeah? Good. Good job. Yeah? All right. So give yourself another score. Yeah? Did you get the whole thing? All right. So you've got image to solution. Let's see the third one. I think this was difficult for some of you to like observe. I think these two red ones are not straightforward, but they're just like smashed a little bit. These two green ones are not straightforward. There's a little bit of like a resizing here. And these two, so they're just, if you copy paste and you just like smash them a little bit, you'll see that they're actually identical. This is difficult one. Did anyone get this one? Yeah? You got part of it? Which one? The green one? The red one, yeah. Okay. But if you got the red one, you should have like, it's the same technique as the blue one. Are you not sure? Okay. Okay. Got it. Okay. Is this clear what happened here? How did they do this manipulation? So this is not just duplication. This is the duplication with alteration, right? So they did something to it. So give yourself a score. So just give yourself like 1 out of, rather than just like a whole score, just give yourself like a partial score. All right, if we keep going on, this one was like difficult. There's just a lot of stuff going on here. And I think many of you found like 1 or 2, but maybe not all the way, right? How many did you get? What's like the best score that we have here? 2, you got 2? Yeah, 2? Anybody more than 2? So I think the difficult one is yellow. Yellow is like a tricky one. But yeah, some of those are like quite obvious. I think the purple one, I guess, is a little bit more obvious. But yeah, that's an interesting one. Okay, moving forward. This, I think some of you had a little bit of trying to find all 6. So we have like, who found all 6? You did? Oh, wow. Well done. Very good. Yeah, that was not easy because they played around with a bunch of things in here. Other than 6, how many did you do in the different groups? 3? At least 3? Yeah, that was difficult. That's increasingly more and more difficult. Look at this one. Rotated, shifted around, duplicated. Like, why would somebody, this just like baffles me. I don't understand. Don't understand this. Yeah, there's like a bunch of stuff going on here, manipulated in all sorts of different ways. If you're not sure about any of those, there's like a link. And I know some of you don't have Twitter, but there's like a link here to her account, to Elisabeth's account, like explaining this whole thing. Here's a decorated version. All the small rounds all look pretty similar to each other. Yeah. So she suggests that this would be like an exercise. This is an interesting one where they just like switch these two. I don't know how many of you got this one. You did? Good job. Yeah, well done. Yeah. So if you're able to do this one, you're like a good image detective. That's great. And finally, this one, I saw some of you struggling with this a little bit. But yeah, we've got two duplications here. Yeah? You found another one? Yeah, tell me. Did you want to show us where? Wait, which team are you again? You're orange, right? Yeah, orange 8. Yeah, 1, 2, 1. Oh, these two.
It seems like they can.
Oh, yeah, the contrast a little bit, yeah. Huh, yeah, good. I don't know exactly if, yeah, maybe I can, once I'm back, I can like check this if they found this or not. Very good. So I think sometimes Elisabeth is like, here's what I found. And then like the Twitter sphere is like, but here's another one and here's another. It's amazing to see like the Twitter sphere work together. I think it's also nice when you work in a group to see people have complementary skills. So some people find one type to be very easy to detect, but completely be blind to something else. But then some people like really combining the power of these things. I should say now that if you follow Elisabeth Bik, she no longer only relies on her eyes. What else can you do if you don't rely on human coders? Machine learning, yeah. Problem is, these tools cost money. So for every scan, they take a few dollars. She's paying this out of the, the Patreon and all of that. And people hire her to do this detective work. But at the very least, you would want the journal publishers for, if they accept something for publication, to run these scans. So now we have machine learning AI tools to be able to detect these things. And they really detect everything. They detect like rotations and scaling and smashing and whatever you want. But these tools cost money. Good. So I wanted you to get like a sense of the work that Elisabeth did. And she's really a pioneer. She saw something that nobody else is seeing. She went full force as an early career researcher, just like you are, and fought everybody in order to establish a completely new way of looking at science. And because of her, science is better off. So sometimes it's not about how many papers you publish. It's really not about that. It's about the kind of change that you can do in order to prevent things like fraud. So imagine that these, we saw the Alzheimer's disease, but if this is like a vaccine for COVID or something that is more serious like cancer, I would want people like Elisabeth Bik to check all the work before I take a treatment or before one of my loved ones needs to use these. So we need to be grateful for Elisabeth. We need to promote people like her. We need to have people like her in our staff, in our teams. We need to collaborate and include them. All right, so we've had this. This is an interesting case study. So I'll just go through the last case studies. When I talked about Brian Wansink, it's really a fascinating case when and this didn't start from like an image duplication. This started from hubris. Hubris is somebody thinking that they're so clever and they can get away with everything that they just go too far. And this is the case that happened. I actually show this a lot to students as early as undergraduate. I give this as an example in all of my talks because this is exactly what happened in my PhD. I don't know what's happening in your labs. I really hope this does not happen at HKU, but I can already tell you that some students that come to my workshops come to me after class and share with me, not at HKU, but in various places around the world, this is exactly my lab. And then I try to support them. I try to refer them to people like James Heathers and other people we'll talk about in order to find how to deal with this condition. So this is a blog post from 2016. So Brian Wansink, after becoming very successful, started giving advice to PhD students how to do well in their careers. His advice here started from a case study. The case study was that he ran a data collection that did not work out. So he went to his postdoc and said, I have this data collection. It's really good data. Find something. So you can see here, this cost us, I said, this is him writing on his blog. I said, this cost us a lot of time and our own money to collect. There's got to be something here that we can salvage because it's cool, rich and unique data set. So he went to the postdoc and the postdoc said, no, I'm not doing this. First, I have my own things. The other is like, you collected this for a certain purpose. It's not there anymore. I don't want to deal with this. But they had a visiting PhD student, happened to be from Turkey. Don't need to make too much of that, but people refer to her as the Turkish student. So it's a visiting student that came to the lab and was very happy to work with a superstar, with Brian Wansink. And Brian said, okay, postdoc, you don't want this? Okay, go do your thing. I'll go to the Turkish student. Went to her, and then they just started going back and forth. Every day she would come to him with findings, a lot of, this analysis and that analysis. And then at the end, they published 4 papers. They published 4 papers from this data set. So every day she came back with puzzling new results. And every day we would scratch our heads and ask why, and then come up with another way to reanalyze the data with it, another set of plausible hypotheses. So you have a rich data set, you run again and again, more and more analysis, and then you try to publish this. And at the end, when you look at the publications, they say nothing about the multiple uses. They say nothing about the reanalysis. And all of them seem to be confirming predictions that they allegedly had before this. So 6 months after arriving, Turkish woman had 1 paper accepted, 2 papers with revision requests, and 2 others that were submitted and were eventually accepted, see below. So he thought that this is good advice for PhD students. The problem with this is that once people saw this, they're like, are you crazy? This is how you run your lab? This is how you do research? Completely unacceptable. So they started looking into his papers, and immediately a host of problems came out. One of them is this thing. He would just like copy paste between papers. It was just like the same exact paragraph. It was just like copy paste. So it was called the Wansink dossier. So they just put all the papers together and had them look at paragraph duplication. So all the highlights that you can see here, it's very, very small, but all the highlights are actually duplications. And it's amazing that nobody has ever looked at this or found anything like that, which is one crazy thing. And very, very fast, Cornell did its own investigation and finally decided to fire him. So many retractions, many problems, many questionable research practices, and issues of fraud. Unfortunately, he still gives interviews to podcasts. He still gives advice. He's still hired as a consultant for nutrition and food companies. Just don't understand any of this. Even so many years after being kicked out, this is still prevalent, and people follow this advice. My request to you, if this is what you're doing, please don't. Like, come to me, we'll have a discussion, we'll talk about why this is not the right way to do science. If this is not clear to you, I'm happy to clarify. For your own sakes, for your own credibility and for your own careers, let's find a different path for you to do science. These are some of the reactions that people posted on his blog. I don't know if you can see this, but at the beginning, people are like, is this satire? Are you joking around, or this is like the real thing? And you can see his replies. It's now you need to go to archive.org. It's not on his website anymore. So if you go to archive.org, you will see his responses saying, what do you mean? Yeah, this is how he did not even understand the implications of sharing that with others. So you pushing an unpaid PhD student into salami slicing null results into 5 p-hack papers, and you shame a paid postdoc for saying no to doing the same. Very strong reactions, and they started this spiral of looking into his data. Also, you would say, some people said, stupidity, hubris. It's like he could have gone many years getting away with this, but he took this one step too far to alert people to what he's doing, and then people were looking into it. So you can see Nick Brown we talked about Nick Brown. So he's the data thug, the PhD student that decided to dedicate his life to building tools to find fraud. So he really started looking into everything in Brian Wansink, and just like one paper after the other, so many issues. And you can see that they actually published either preprints or actual published articles saying all of the problems. So Tim and Nick Brown, people to follow. So 52 publications from Brian Wansink, which have been cited 4,000 times, published over, I think this is like from 3-4 years ago, 13 articles retracted, some of them corrected. I don't know what kind of correction they were doing, but we were just like baffled by why this is corrected and not retracted. And very, very strange reasoning that he gave for all of the things. So you can see all the big headlines. 6 years ago, this was like a big thing. Big scandal in the food nutrition. And because he applied nudges, it also affected us in JDM and social psychology. This is Nick Brown. Not exactly what you have in mind when you think about a PhD student. How come he's 50 plus years old and he is a PhD student? He left a good job to become a PhD student so that he can clean up science. To me, that's admirable. To me, that's something very, very unusual. I invite you to look at his TEDx talk, not in a train, like in front of an audience. Very, very, very good talk, saying, I don't want to do a regular PhD. I want to do a PhD that would matter, that would have impact in cleaning up the literature from people like Brian Wansink. So a lot of very interesting papers to read, but then they started coming up. So here you see Nick Brown with James Heathers. James Heathers has also left academia. He's now part of, I think, a startup, but he still is part of the podcast Everything Hurts with Dan Quintana that we talked about in the previous session about meta-analysis. Dan Quintana is like the very charming, like the nicest person. James Heathers just like curses in every other sentence, very blunt, in your face, doesn't give couldn't care less about anything but scientific validity. And they started doing tools together. So the question is how to detect fraud. If we see a paper, if you want to build your research on something, and you read an article and you say that this is unlikely, like there's just absolutely no way that this is true. How can you prove that? How can you find how likely this thing is? So they started coming out with all sorts of tools like the green test. So it's a technique that takes the raw descriptives, not the raw, you don't need the data. You just look at the descriptives, you take the mean, the standard deviation, and the sample size, and you see whether this is likely or not. They started doing this after Brian Wansink, which was 2016. 2017, people asked them, but how do you know? How do you know that this is fabrication? How do you know that Brian Wansink really did this? They said, we'll show you. So they came out with this series of tools. The first one is really the green test. So this is like one example from one of the papers in Brian Wansink. They just took a bunch of statistics that were in there and just showed that some of these statistics are completely improbable. Like there's no way that these statistics actually represent a real data. How to do this? Like what's behind this? I don't know if, we don't have time for this, but if you want to hear, if you remember Neuroskeptic from the 9 Circles of Hell, so Neuroskeptic came out of his spot in order to talk about Brian Wansink and everything that has happened. So if you want to listen to him talk about this on video, this is a good summary of all that. I just want to say how Brian Wansink finally responded to all of this. At the beginning, he denied everything. But after Green Test came out, and after all these tools came out by James Heathers and Nick Brown, finally came out with this. As a researcher, I'm very sorry for any mistakes I have made in my papers. Mistakes. I apologize about how they negatively reflected on my colleagues, my wonderful school, and social science research in general. When we saw this, of course, we did not like this kind of reaction, because it doesn't really, just like with Diederik Stapel, does not take responsibility for everything. But I also included some of the responses from PhD students, which I think really broke my heart, because I know what it means to follow research that is not solid. So much of my work as a grad student was based on your research. I failed to replicate any of your work. It is so frustrating to have tried to add this to important area research and learn that it was basing it on your mistakes, which you have benefited personally from. Definitely a lot of consulting work and gigs and all sorts of things. How many of the research in your book, Mindless Eating, is mistakes? I'm going to play to you a little bit from from James Heathers and Dan Quintana, from their discussion about how things came to happen with Brian Wansink. We don't have a lot of time, so I'm going to keep this rather short, but it's like a whole hour of them discussing this case study.
Now, that's what I'm talking about. There is a perspective in science where we uncritically accept conclusions. We are interested in the outcomes of things. We read abstracts and discussions and a little bit of the intro and then say, I like the way these ideas fit together. Let's roll that into what I'm studying. Let's roll that into my grant application. Let's refer to that in my own construction of ideas. And that can go to, it doesn't always, but it can go to such an extent where you have things that cannot possibly be true sitting in plain sight in very popular papers, when no one has ever had the presence of mind to go, hang on, that's totally impossible, and it's totally impossible in a way where I think I could explain how it was impossible to a 14-year-old most of the time and have them go, yeah, but that's like, yeah, of course that can happen. That's totally wrong or whatever, which is how all 14-year-olds sound in my head. So those are the maintaining factors. The fact that people occasionally rely on having a sounding board for this, and there's no formal mechanism for any of it to happen. And it's when it's bad, it's quite bad. So that's the story of like where it's from and how it manages to maintain itself, because I do have a normal job that I do all day. People don't really pay me to do this. I mean, I would like them to. I've asked for money to try and make that the case. If anyone's got an idea of how to expand a program in meta-science research, that I call it my 6 o'clock job, because after I finish working during the day, a lot of the time I sort of turn myself over to whatever in my inbox or whatever's being looked at the time. So obviously it's not sustainable, but if anyone's got any ideas on how to make it more sustainable, I'm all ears, and the rest of the world's already writing to me in the first place.
And back then he was a PhD student. He wasn't sure whether he's going to be able to find a job, just like Elisabeth Bik. Since then, we've discovered Patreon and other ways to support people like James Heathers, but he's lucky he was able to find a job in industry. All right, so since they started doing this in 2017, Nick Brown, I think, also graduated recently, finally. They came up with more and more tools, Sprite, Grim, and Grimmer. And we'll see a little bit of how they do this. So they have apps for everything. This is one of the apps by Nick Brown. So I'll just give you an example from this paper that they published. So for example, here you have, let's say, an N of 3. A mean of 2.5, and you ask yourself, is this possible or not possible? So you can see here, it's like you can give the entire scale, you can give the sample size, you can give the target mean and the standard deviation, and then it will show you the distribution so that you can decide if this looks like real data or not. Grimmer is like an updated version of that. Okay, so here you can just see like how simple this is. So you just put in sample size mean, and it tells you if like this is reasonable or not. So for example, here you have like So if, for example, your sample size is 10 and the mean is 3.63, then it says inconsistent, cannot be. Why? Because it cannot be, it has to be like multiples, something that would seem reasonable. So if, for example, I don't know, this is like 6, it seems like consistent, but because you've got this decimal, it seems inconsistent. And then it also has influence for the number of items. So if there are more items, then it seems more reasonable. So if you have the number of items, the sample size, and the mean, and something doesn't make sense to you, this is like the first tool that you can try. Since then, there are a lot more sophisticated tools that also look at the standard deviation or the standard error of this, so, or even just like the variance. So you can like choose which one of those you want to look into, whether it's the sample, the population, or even if you don't know. And then you enter like what is the standard deviation for something and then see if this is reasonable. Oh, so I even have an example here. So for example, is a standard deviation of 0.2 possible when you have a sample size of 25? It's not as intuitive as a mean. So with the mean, it's like, should it be like a round number or not a round decimal? But with standard deviation, it's a little bit more tricky. So Grimmer first checks for Grim. So the same thing like means in Grim, but also checks the standard deviation, the standard error, and the variance. I've already used this like as a second examiner on all kinds of theses because we don't get, I don't even know why, but the department refuses to ask PhD students to post their data. Even I found the second examiner. But sometimes I like reverse engineer things with these kinds of tools. So when I see something, I'm like, did the student really run this analysis? Like something doesn't make sense here. I just put it here and then I see whether this is possible or not. Many times I ask questions and then the student's like, oh, sorry, bad copy paste. And then everybody's happy. But I suspect that in some cases, this is a little bit more than that. So I invite you to like play around with this and see. So for example, a standard deviation of 0.13 is not possible, statistically possible when you have a sample size of 25. So a lot of things that you can play with these kinds of tools. Now we have even more advanced versions of this. It looks a bit like COVID, but it's Corvid. And here you can have like a nicer interface where you put also the minimum value and the maximum value. It's unbelievable that up until 2017, nobody created these tools. And you needed 2 PhD students, James Heathers and Nick Brown and Tim, and to create these tools. And they're not even statisticians. They're just like psychology students coming out from nowhere in order to do this. So just unbelievable. The last thing I want to share, the issue with Dan Ariely, just to give you a glimpse into all sorts of things that we should be talking about more with PhD students. Should I show you the video? Yeah, why not? Like he's very charming. I hope we have enough time for this.
Now, how would you test a personal fudge factor?
Fudge factor is what the amount of cheating, what people can justify in order to cheat. So he's talking, he has a whole line of research about why people cheat.
We said, what can we do to shrink the fudge factor? So we got people to the lab and we said, we have 2 tasks for you today. First, we asked half the people to recall either 10 books they read in high school or to recall the 10 commandments. And then we tempted them with cheating. Turns out the people who tried to recall the 10 commandments, and in our sample nobody could recall the 10 commandments, but those people who tried to recall the 10 commandments, given the opportunity to cheat, did not cheat at all. It wasn't that the more religious people, the people who remembered more of the commandment, cheated less, and the less religious people, the people who couldn't remember almost any commandment, cheated more. The moment people thought about trying to recall the 10 commandments, they stopped cheating.
Now, in 2012, I gave my first course ever as a PhD student, and I remember this coming out, and I implemented this as an honesty pledge at HKUST students in order to try and reduce cheating. I did not ask them to do the 10 commandments, but I asked them to recall the non-existing HKUST moral code and to sign that they will abide by it. So this is the main idea. It came out in this paper in 2008. And I was definitely convinced by this. And they said they have a lot of political implications and just like a bunch of nice things. Many experiments came out of this. Yeah, and this one, experiment one, has not been directly replicated. There's this 10 commandments versus 10 books and all of that. And finally, many years later, they decided to do a mass replication effort. And you can see both all authors, including Dan Ariely, Nina Mazar, and On Amir, participated in this mass replication, vetted the protocol and all of that. And you can see that in the replication, the original effect size, which we already know is very large, is this 1.45. But the result was that you've got a null effect overlapping with the null. Very, very weak here. Here's a follow-up video from a talk explaining a follow-up study.
We ran a similar experiment, by the way, with a big insurance company. The only thing we did was we changed the line on the signature. You know, usually in insurance form, you fill the insurance form and you sign at the bottom. By the time people sign at the bottom, they finish cheating. It's over, right? So we changed the line and we got people to sign up front. Turns out people cheat much less when they first sign.
Yeah, so I implemented this in my exams and all sorts of things. That at the beginning there was an honesty pledge, and this is based on a lot of things. This is the paper that talks about whether signing at the beginning, and you can see Francesca Gino and big names like Max Bazerman talking about this working. And the interesting thing was really this third study about the insurance company. So they got insurance company and they asked them to manipulate that, whether people are signing at the beginning of the tax form or at the end. And then they saw a big difference between these two. So this has been like all over the news. Just to wrap up this whole thing is like after we failed to replicate this many times and people said this just doesn't work, all of them started to come together and decide to do replication. So you see the same people, Bazerman, Gino, Shu, Mazar, Ariely, together with two others, decided to do a replication. And it's amazing because the replications, of course, did not work, but they've published this. They published this in PNAS. So for the first time, original authors take responsibility, do replications, and publish this in the same journal where this was originally published 10 years later. Problem is, when they published the replication, they shared all the data of the replication, and they shared all the data from the original article. And this is what happened. Data Colada, which is Uri Simonson together with two others, came to the decision after doing a very big analysis, evidence of fraud in influential field study about dishonesty. So basically, they looked at the data from the insurance company and they said, there's absolutely no way that this was collected. So they gave a lot of evidence for this. So for example, one of the things that Uri Simonson is famous for is if you ask people, how much did you drive? Usually you have like a bell curve like this. This seems reasonable. But what you saw in the insurance company is that it was like all of them were the same. If you did 5 kilometers or if you did 50,000 kilometers, it's like it was about the same distribution. So somebody just like randomized data. So this is just, it looks like randomized data. All sorts of other evidence, I won't go into this, but the most conclusive evidence was that in the actual data set that was in Excel, 2 different fonts were used for what seems like the original data and what seems like to be the manipulated data. So somebody very not clever did this. Somebody manipulated this, and it's very, very obvious. So you can see Uri Simonson, Joe and Leif published this in 2021, and we were just like shocked by the whole thing. We asked all of the authors, like, what's going on here? Many of them responded, yes, you're right. Thank you for finding this. This is very important. Dan Ariely is like, yes, insurance company, very sorry about this. Just unbelievable that we found this. To me, this is a very, this was a success story for open science because original authors do a replication and then they share everything and then we find data fraud. If we did not have access, we would not find this out. Max Bazerman did a book, just recently published a book where he reflects about his own participation in this. He doesn't say that he knew anything about this, but he said, when I received the data, I really thought this is too good to be true. But because this is Dan Ariely, because this is Francesca Gino, I did not say anything, and I was willing to go ahead and put my name on it just based on trust. So I urge you to go and to listen to him reflect on this and to read his book on the section where he writes about this. And finally, this was retracted at the end. Yeah, if you want to hear, so since then, a lot of things have happened. I'm going to make it short because we're at the end of the session. We can't figure out who did this fraud, but once you have one case of fraud, people start looking into Dan Ariely. So I grew up in Israel. I can understand Hebrew. And a TV show in Israel, Dan Ariely is considered to be a big hero and scientist in Israel. A big TV show called Hamakor, it's The Origin, went and did a whole series of interviews to try and figure out what's going on with Dan Ariely. They found out that, for example, we did not know, but he was expelled from MIT and had to move to Duke because he gave electric shocks without IRB. All sorts of discussions about how this happened. He has what sounds at the beginning to be like a good excuse to this, but then started a series of, we don't know who ran a lot of his studies, a lot of things that he claims that he did on the YouTube TED Talks and in his book, we just have no support for. So a series of interviews, including one with him where he admits that he is wrong. He does not admit to fraud. He just says that he did not pay attention to details and he did not document things enough. So PhD students or big superstars, if you really are honest, I don't know what's going on in Dan Ariely. It just doesn't look good right now. But he doesn't have answers to the most simple questions of who ran this, at what stage, where is the original data, who is responsible. He just doesn't know. And then it's very easy to just say, oh, it's the insurance company. Oh, it's the research assistants. Oh, it's the PhD students. And that's a very unfortunate turn of events for all of this. I recommend that after this, you click on some links. For example, this TV show, looking into Dan Ariely, now has English subtitles, so you can watch the whole thing. It takes like about an hour. I run this in like 2 times speed to look at the whole thing. There's a lot of things that we can all learn from that in how we do our research, how we do our collaboration, how we document everything. So going back to the thing that we raised at the beginning of the session, which was the main point that I wanted to drive for you. Sometimes being honest is not enough. You will forget things. You will have a lot of collaborators. As you embark on your journey, you will have a lot of people that are involved in your research. Have a good mindset to do good research, document everything, check everything, look into everything, make sure that what you're involved in is done and in a solid way. Protect yourselves. It could come from any kind of direction, but at the end, it's up to us to make sure that our collaborations, that our research, the things that we rely on are solid. So this fraud session is needed for you to know the kinds of threats, to know what it is that's happening out there, even with big superstars. It's probably more prevalent than we would like to think. And to also deliver the message that some of the biggest achievements in fighting fraud, some of the best tools that we have out there came from PhD students. So you can take part in this. You can be an image data detective. You can build tools. You can contribute to the academic community, not just by providing more papers, but by also revisiting and doing work that looks into other people's possible potential fraud. So that's kind of like the end of the story here. Perhaps next session, I'll talk a little bit about Francesca Gino. But if you're not familiar with this, maybe talk to some of the other students who are knowledgeable and look it up, because there's some implications for all of us in these stories. Yeah, sorry for keeping you a little bit longer. Hope that you found this insightful. I'll see you next week.